Now, when we look at time value of money, we talked about the concept of it, and I want to compare it to an actual formula that you use to adjust for the time value of money. And this is where you come into the concept of present value. So you can do present value of a lump sum or annuity. We're going to talk right now about a present value of a lump sum. So what this would mean is you're trying to set a value of money that you're going to receive in the future as to what its value is today. So, for example, if you receive the dollar in the future, what is the value, the present value of that dollar? Initially, you think, oh, it's still a dollar, but it's not because, in this case, of inflation. It's costing you, um, some erosion of your purchasing power every year. As inflation happens. So the formula for this is the present value of a dollar in the future, or today's dollar value, is equal to the amount that you're going to get in the future times 1 over 1 plus I to the n. So the amount is simple. That's just what you're going to receive. I is the discount rate, which is, in this case, the inflation rate. So what you're going to do is you're going to adjust it for the purchasing power of what you can buy with that dollar in today's terms. And n is the number of years in the future that you're going to receive the money. So clearly, by looking at the formula, the higher the n, the longer it takes for you to receive the money, the lower the present value of that. And that should make intuitive sense. So something 10 years from now is worth less than something 2 years from now. Now let's do an example. If inflation is 3% a year, which is not far from where it is right now, what is today's value of a dollar received in 5 years? So another conceptual way of saying that is, if you were going to be equal, and I give you a dollar in 5 years, how much would I need to give you today to make it exactly equal in terms of purchasing power? And the way you'd calculate that is by using that formula. So the formula is one way. There's a present value table we're going to use in a bit, but let's do the formula. It's pretty straightforward. So the present value of that dollar is equal to the amount, which is $1, times 1 over 1 plus the inflation rate of 3% to the power of 5, which is the number of years in the future. So it works out to 0.8626. So another way of saying that is 82 or 86 cents today is worth about the same as a dollar in 5 years. And both would allow you to buy the exact same amount of items. If that was the inflation rate going forward, you'd be really neutral whether you got the money, the 86 cents today, or whether you got the dollar in 5 years. So the left part of the equation is the amount. I used a dollar. It could be 200, 1,000, whatever you want. And the right part of the equation is just substituting in the variables of the formula. I was the inflation rate and n was 5. So this whole component here is called the PV factor, the present value factor. So if you didn't want to use the formula, you could just plug in the PV factor from the present value tables. And they're published online. And here's an example of the present value table for a lump sum received in the future. So you go to the column to find your inflation rate, which was 3%, and the row is the number of years, which is 5%. And you can see when you go across, the PV factor is 0.8626. So this essentially is just a multiplication of that right-hand part of the formula. So if you instead of wanting to use the actual formula, you could just take the amount and multiply by the PV factor and get the same answer.